Hello everyone. So in the previous video, we discussed the concept behind the problem 3 sum. In this video, we will be implementing the solution that we discussed. Briefly speaking, that was that we fix an element at a time in the outer loop. On the inner loop, we use 2 pointers and we test out the combination of the 3 elements and we keep moving them around to see whichever elements fit best and gives us the sum as 0. But before all that, we of course sort the array so that it is in ascending order. So that's what we'll be implementing. So let's start off right off the bat by sorting our array. So in JavaScript, the way to sort an array of integers is something like this. So we have the sort function and we'll define it to sort the values in ascending order. If you want it to sort in descending order, you simply do b minus a. I will leave this part for you as homework to understand exactly how this works. And if you want to test out your knowledge of loops, you can just sort it in descending order and then implement the solution that I'm about to implement right now. Now, coming back to what we discussed, we have 3 pointers with us, right? The first pointer, which is at the very beginning, the second pointer, which is starting off right next to the first pointer, and the third pointer, which will start off at the very end. Now, while this first pointer is less than the second pointer, we move on, we keep on testing out one value at a time for the first element, which starts at index 0. But every time this loop starts, we have to reset the values of the second and the third pointer as we discussed. So the second pointer at the beginning of this loop becomes the value that is right next to the first pointer, and the third pointer comes out to the very end of this array. And now that we have our second and third pointers in place, we have to start our inner loop. In our inner loop, of course, the second pointer's range goes all the way from being right next to the first pointer till it reaches the third pointer, which is why we have this condition. Here, what we do is we take out the 3 values. So the first number will be found at the first pointer. Similarly, we get values for second and third. Now that we have the 3 values in place, let's calculate their sum. Now we have 3 cases. This sum could either be equal to 0, which is what we want, or it could be less than 0, or it could be greater than 0. So let's write down all the 3 conditions. Okay, so we have 3 conditions in place. So if the sum is equal to 0, we need to have an answer variable that we will be eventually returning. And if the sum is equal to 0, we will simply push these 3 elements inside an array, which will be pushed to this answer. That will make up our 2D array. Then we will move the second pointer around to the next position and we will test out for more such combinations. Now keep in mind, one of the reasons why we sorted this array first was so that we can avoid having duplicates in the same place again and again. So we will move the second pointer forward, but we will keep in mind that while the second pointer is in its valid range, that is, it is before the third pointer, and the new second pointer that we do have, its value, if it happens to be the same as the value that was there when second pointer was at the previous position, which was the one right before it. In that case, we have to move the second pointer again because we've encountered a duplicate value over here, right? So we keep moving it forward till it is in the valid range and till there is a duplicate that we find out. So we do that, and if the sum happens to be less than 0, which means that we are looking for a bigger sum, right? Now, our third number is already at the last position. It can't go any beyond any more, in the forward direction because it is at the very last position at this moment. So our only scope, if our first element is fixed, is moving the second element around. We need a larger value. We have a sorted array, right? So if we are over here right now, let's say we are over here, that is the second element. To get a larger value, we have to move in the forward direction, right? So we repeat this exact same logic over here. Then, if our sum happens to be greater than 0, which means we need a smaller sum. If we need a smaller sum, we need to move from a bigger value to a smaller value. So we will move the third pointer and we will move it backward. For simplicity, we've fixed the movements. We've fixed the movement. The first pointer can only move forward. The second pointer can only move forward. The third pointer can only move backward. That keeps the solution simple. It makes it easy to understand, and it's at the best complexity that it could be at. So we do the same thing with the third pointer. Its valid range is that it should be in front of the second pointer, and if we find out a duplicate, which basically means that if the new third pointer is the same as the value that was present at the previous third pointer, which was the one right ahead of it, we move this third pointer backward. Alright, so that is basically how you loop it. The question remains that how do you move the first pointer forward? You keep it quite simple. You move it, then you check for duplicates while keeping the first pointer in range. Now I say that the first pointer should go on all the way to the very end, right? So while the first pointer is inside the array and, well, the same condition as before, that if the new first pointer, the value at it, is it the same as the one that we had previously for the first pointer? If that is the case, then just keep moving forward. No need to test this again because we've encountered a duplicate. So that is how you move the loops. And once all is said and done, you simply return the answer. So let's try to run this. All right, our basic test cases have been accepted. Let's try to submit our solution. And there you go, our solution has been accepted. Thank you so much for watching and follow for more.